Hi grade 8s. This is the last topic on fractions, you'll be pleased to know. And this topic is on using bar models to solve word problems. Now, I think we see the word problems and fractions, and parts of us just want to sink into the ground and our heart starts to beat faster. And I probably would have felt the same until someone introduced me to bar models, and it's completely changed how I view these problems. Bar models are just such a wonderful way to help yourself make sense of a question. Now, I think the difficult thing about these questions and bar models is that sometimes the bar model is useful to work the whole question out, and sometimes the bar model is just useful for the beginning bit to figure out the question, and then you can use normal maths. And so you'll notice as we go along, sometimes I use bar models for the whole thing, and sometimes I just kind of use it to help myself. So let's just go through these questions quite slowly. Bar models will probably be fairly new to you, and so we must just make sure that we understand how useful they are, and how we can use them. So let's look at the first question. Each month, Sydney spends 1/3 of her salary. Okay? Then she saves 3/8 of the remainder. Now, that's really an important word because she doesn't save 3/8 of her salary. She saves 3/8 of what's left behind. And then the rest, she shares equally amongst her mother, brother, and sister. Okay, now what a bar model is you start with a bar that represents the entire situation. So I start with a bar that represents her entire salary. Now, Sydney spends 1/3 of her salary. So I'm going to divide this into 3 blocks because she's going to spend 1/3. Now, before I go any further, I must point out that you can never have bars of different size. So if I divide them into 3, I must divide into 3. If I divide now one of these parts into another 4 blocks, everything must be divided into 4. And so just make sure that your blocks always should be, they don't have to, these don't look exactly the same because I'm not measuring this properly, but the idea is that each block is equal. So here I'm arguing that Sydney spends 1/3. So that first bit here, she's spending this. So that's gone. Now, this remainder, she needs to save 3/8. So these 2 blocks need to be now divided into 8 blocks because I need to be able to say she saves 3 of the 8 blocks, and I don't see 8 blocks there. So in order to make this 8 blocks, I'm going to divide this block into 4, which you're absolutely allowed to do as long as you divide everything into 4. So 1, 2, 3, 4. Why? Because I now have 8 blocks. But remember what I've said, if I've divided those 2 parts into 4, I must divide this first part into 4. So you'll notice now that there's actually 12 blocks. So if I look at this as a whole, there's 12 blocks, and I am arguing that she has spent 4 out of the 12 blocks. So 4 out of 12 blocks she has spent. Now you'll notice that simplifies to 1/3, which is right. Now I can fill in what she has saved. She has saved 3/8. So 3 out of those 8 blocks of the remainder. Remember, not 3 out of the 8 of the whole. 3 out of those 8 remaining blocks she has saved. So those are the saved ones. Now finally, the rest of this, now what is the rest? This is the rest. The rest are 1, 2, 3, 4, 5 blocks. So when we talk about the rest of her salary, after she has saved and given, and she spent some, the rest of her salary are 5 blocks out of 8. So let's read what we have to do with this 5 blocks out of 8. So, now you see, I'm lying to you already. 5 blocks out of 8, no. Remember, the whole is 12. 5 blocks out of 12 blocks, my apologies. So yes, 5 blocks out of 8 of the remainder, but if I'm looking at the whole of her salary, it's 5 blocks out of 12 of her salary, her whole salary. So this question says, what fraction of her salary does each of them receive? Now, who's this question talking about? Well, there's 3 people she's sharing this amongst. She's sharing them amongst her brother, mother, and sister. So I need to take these 5/12 of her salary and divide it into 3. Now, I don't really want to go divide all of these blocks into 3 now, because then I'm going to have loads. I'm going to have 36 blocks. And so this is a good point to me to say, you know what? this bar model was useful. It's helped me figure out what fraction I'm left over with to share out. But now it's easier for me to say I've got 5/12 of her salary and I'm dividing them amongst 3 people. So I've abandoned my bar model because it's helped me as much as I want it to help me. Now how do I divide? Well, it didn't say I couldn't use my calculator, but if I want to do it in my head, I'm going to tip whatever I'm dividing by, and so I'm multiplying by 1/3. And so this is 5, top times top, bottom times bottom. Each member of her family will receive 5/36 of her salary. Cool, hopefully that makes a lot of sense. Now, without the bar model, I probably wouldn't have been able to figure out that she has 5/12 of her salary left over. Remember, not 5/8 like I said initially. I was saying 5 out of the 8 of the remainder, but of her salary, it's 5/8. Now let's look at the second question. If her salary is 5,400 Rand, how much does her mother get each month? Well, this isn't anything to do with the bar model. This has got to do with the fact that her mother receives 5/36. It's a hard word to say, 5/36 of her salary. So it's 5/36 times 5,400 Rand. Now again, this doesn't say that I can't use a calculator. So I would pick up a calculator, and especially with such big numbers, and do 5/36 times 5,400. And I get the fact that her mom receives 750 Rand a month. Great. Let's look at another one. These get to be so much fun. Right, this question says, Blanca used 2/3 of her garden to plant tomatoes and another 1/9 to plant lettuce. So if I just look at the whole concept initially, she needs to use 2/3 of her garden. So 2/3 of her garden. So these parts here are her tomatoes. So she's left with 1/3. Now this question says she also then plants lettuce in 1/9 of the garden, not of the remainder. This is 1/9 of the garden. Now the problem is the way I have divided my blocks, I don't have 1/9. I only have this into thirds. So in order to make these into blocks of 9, I need to divide each of these 3 blocks into 3. So 3 in that block, 3 in that block, and 3 in this block. Now I have 9 blocks overall. So now I can say that this 1/9, so this 1 block out of 9 is for lettuce. These tomatoes are actually 6 blocks out of 9, which is the same as 2/3. Great, let's read on. She then divided the rest of her garden. So this is the rest of her garden, which is at the moment 2/9. She divided into several plots of land. Each plot of land represented, 1/18 of her garden. Now, I don't have 18 blocks. I have 9 blocks. So how do I take these 9 blocks in the total and make 18 blocks? I would have to divide each block in half again. Now remember, what you do to one part of the bar model, you do to everything. So everything is getting divided in half, simply so that I will then have 18 little blocks. So actually this is now, if you count them up, I've divided everything in half, and so this is 12 over 18. So 12 blocks out of 18 are for tomatoes. If I look at the lettuce, it's 2 blocks out of 18, which is 1/9. So if I look at the rest of my garden, each small plot represents 1/18. So there would be 1/18, that would be a small plot. There would be 1/18, that would be a small plot. There would be 1/18, that's a small plot. And so finally my last small plot. So now my first question is already answered. How many small plots of land are there? There are 4 small plots of land. And finally, if the area of her entire garden is 72 meters squared, what is the area of each small plot? Now this particular question you wouldn't actually have to have drawn a bar model for, and if you couldn't do the first question it wouldn't matter, because they told you each plot of land, the small plots, are 1/18 of the area. So all I have to do is 1/18 of 72. Again, I would probably use my calculator, and I would get that it's 4 meters squared would be a plot of land. So basically each of these blocks represented 4 meters squared, and so you basically have 18 little plots of 4 meters squared, and 12 of those blocks would be for tomatoes, 2 would have been for lettuce, and then you had 4 of these 4-meter squared plots. Cool, so that was a fun one. Let's carry on. Question C. 3/5 of the pupils in the class were boys. The teacher divided, okay, now, before I even move on, let me just draw in my 3/5. So there's my entire class. I'm going to divide it into groups of 5. So 1, 2, 3. Well, now these don't particularly look very even, so let me try that again. 1, 2, 3. That looks much better. So 3/5 the class are boys. So there are 3 parts out of the 5 parts are boys. The teacher divided the class equally into groups such that each group represented 1/10. Now the problem is I can't draw 1/10 here because I only have 5 groups. So my 5 groups need to become 10 groups. How do I do that? I divide every single bar in half, because then I will have 10 little blocks and I can figure out where 1/10 is. So this is 1/10. So now the boys are made up of little groups of 1/10. They actually are made up of 6 little groups of 1/10. And actually that's all just about converting to an equivalent fraction, right? So there we go. The teacher divided the boys into equal groups such that each group represented 1/10 of the number of pupils. So there's 6 groups of boys. The teacher then divided the girls equally into groups such that each group of girls had 1/5 of the pupils in the class. So the girls, this entire group there are girls, but she's dividing up all those girls into groups so that they represent 1/5 of the whole class. So that there is 1/5, and that there is 1/5. So in actual fact, I'm going to combine those 2 groups together to form 1 group of girls, and those 2 little groups together to form 1 group of girls, simply because each group of girls had to represent 1/5, so 1 block out of the 5 blue blocks. So what's the question here? First question, find the number of groups of boys and the number of groups of girls. Well, we've already answered that question, really. There are 6 groups of boys, because those small blocks are representing 1/10, and there's 6 small blocks. And there are 2 groups of girls, because the girls had to be 2 of the little blocks. And our last question, if there were 16 girls in the class, so these girls represented 16. How many boys were there in each group? So not how many boys were there, how many boys in each group. Now, if there's 16, I need to know, what does 1 block represent? So basically 4 of these little blocks represent 16 people. So what would 1 block represent? 1 block would represent 4 people. Now this is a very useful concept in bar models. It's often very useful to figure out how many people or how many things or how many rands, whatever, in 1 block. Because now I know that this is 4 girls, this is 4 girls, this is 4 girls, and this is 4 girls. So that means there's 8 girls in each of their groups, because they were divided into groups of these 2 of these blocks together. So that means there's 4 boys there, 4 boys there, 4 boys there, 4 boys there, and 4 boys there, and 4 boys there. So now you can answer anything. You can answer how many boys in each group, how many boys in total, how many children in the class. What was the question here? The question here was, how many boys are there in each group? Well, 1 of these blocks represented a group, so there are 4 boys in each group. Okay, again, a really nice question. Cool, let's soldier on. The more we do, the better we get. Oh, this is a nice one. Sophia read 1/6 of a book on Monday. Okay, so the moment I read information, I like to start drawing, because just take it 1 step at a time. So 1/6. So 1, 2, 3, 4, 5, 6. So she read this part on Monday. And another 1/3 of it on Tuesday. Now, the problem is I've got 6 blocks. I don't have 3 blocks. So I need to decide, what does 1/3 equal out of 6, because how many blocks out of 6 will that be? So if I multiply by 2, I multiply by 2, I realize that it's 2 blocks out of 6 would be 1/3. So both of those blocks will be read on Tuesday. Now immediately I can tell you how much of the book she's read. She's read half the book without even doing much maths. The next question said she took another 4 days to finish reading the book. So this part here took me 4 days. So basically 3 blocks out of 6, or half of the book, took her 4 days. She read the same number of pages on each of these 4 days. Okay, so there's the same number of pages on each of these days. Now, it looks like I've written the same sentence twice here. So she took another 4 days to finish reading the book. So let me cross out that sentence there. She read the same number. So we basically need to take those 3 blocks and divide them into 4. Now, this is the point where you have to ask yourself, should I continue with the bar model and divide each of these blocks all into 4? Or is this a time where I go, okay, let me just rather revert to normal maths? I would personally prefer to revert to normal maths, simply because I know that basically half the book needs to be divided into 4 days. Now, that's not a particularly difficult sum to do, whereas dividing every single one of these blocks into 4 might be a little bit more tricky. So basically, I could take 3 blocks out of 6, or I could say, well, it's half the book, and I'm dividing them into 4 days. Again, you could do this in your calculator, or you could do this in your head, a bit of a long way. And so tip and times, and 1 times 1 is 1, and 2 times 4 is 8. So what fraction of the book did she read on each of these days? She read 1/8 the book on each of these 4 days. Now notice that's not represented in the bar model. That's not one of these blocks, because one of these blocks is 1/6. That's not what's going on here. So 1/8 isn't now physically in the picture, but I do know that I've taken this part of the book and I've divided it into 4 sections, and that's 1/8 of the whole book. And now it says, if she read 30 pages on each of these 4 days, find the number of pages in the book. So a couple of ways to do this. Basically, there's 2 main ways how I would approach this. Either what you could say is you could say 1/8 of the book is 30 pages, because they told you that she read 30 pages on each of these 4 days, and each of those days represented 1/8. So if you wanted to find out what the whole book was, I could basically say, well, I have 8 eighths. I have 8 sets of these. So basically the whole book, and I could multiply by 8, and I could get 240 pages. Now that's one way to do it. What about, or you could say, I have 4 days of 30 pages. And 4 days of 30 pages would give me 120 pages in total. Now that means that this bit here, all of this, represented 120 pages. Now that 120 pages is half the book. So this is half the book. So therefore the whole book would just be double that. So therefore the whole book would be 2 times 120, which gives me 240 pages. So same answer. Notice here I never once found out what 1 block was worth, simply because I stopped before I was actually working into blocks. I stopped because I had to divide into 4 and it was too much effort. So in this particular example is an example of where the bar model helped me to make sense of the book, but then I abandoned the bar model once I'd gotten to a certain point. Right. Another one. In a class, 2/7 of the pupils are girls. Okay, so let me draw my bar model. And I need to divide it into 7, so 1, 2, 3, 4, 5, 6, 7. So 2/7 are girls. So there we go. This is 2/7. 2 blocks out of 7 are girls. Half of the girls, so if there's 2 blocks are girls, half of the girls would be that, half of the girls, and 1/3 of the boys. Now, here are the boys. Now, how many blocks are the boys? 5 blocks out of 7 are the boys. So when it says 1/3 of the boys, is it easy to take 5 blocks and to divide them into 3 equal parts? Well, no. So this is an example again of, do I now go and divide each of these blocks into 3 parts so I can pick out 1/3? Or do I go, okay, this has made enough sense and I can move on? So let's continue reading. Half of the girls, so 1 block, and 1/3 of the boys, which I can't currently display, wear glasses. Okay, 10 boys wear glasses. Now, the moment I see 10 boys wear glasses, I don't think I have to continue with my bar model, because 1/3 of the boys wears glasses. So 1/3 of the boys are 10 people. So how many boys? Well, if 1/3 is 10, I can just multiply by 3 and get 30. So what I'm arguing here is I can times by 3, so I get all the boys, and times by 3. So now I know that these boys represent 30 people. How many girls wear glasses? Well, it might probably be easiest now to realize that 5 blocks represent 30 people. So therefore 5 blocks represent 30 people. Now again, I might now want to revert back to my bar model, because can I find what 1 block is? Because that will be really easy. And so 1 block, if I divide by 5, 1 block represents 6 people. So this is 6, 6, 6, 6, 6. So how many boys? Well, there's 30. That makes sense. How many girls? There's 12 girls. But the question says, how many girls wear glasses? Well, there was only 1 block that wears glasses. So therefore, 6 girls wear glasses. So this is a wonderful example of where it actually helped to kind of leave the bar model alone and figure out how many boys there are, but then go back to the bar model. I really hope that you're getting the hang of these and starting to enjoy them, because they really are fun. Okay, on to the last one. This is probably my favorite example, because this is the example that convinced me that without a bar model, I wouldn't be able to do this question. So this question says, at a concert, 2/3 of the audience are women. So immediately I am tempted to go and divide my bar model into 3, and why not? So all of these are your women. 1/5 of the audience, not 1/5 of the leftovers, 1/5 are men. Okay, now this is a problem. I can't see 1/5 here because I've gone and divided my bar into 3. So I need to be able to divide into 3 and to divide into 5. And so I actually need 15 blocks if I'm going to answer this question. So I'm going to go and divide each of these into 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many women? Well, there's 2/3. But if you now look at the fact that there's 15 blocks, if you count them up, there's 10 blocks out of 15 which are women. Now this question then says 1/5 of these are men. So if the men equals 1/5, how many blocks would that be out of 15? So I'm timesing by 3, timesing by 3. An equivalent fraction would be 3 out of the 15 would be men. So there's my men. So far, what have I got? I've got women, which represent 10 blocks. I've got men, which represents 3 blocks. And so how many leftovers do I have? I've got 2 blocks left over. And what does it tell me? The rest were children. So these 2 blocks here in green are my children. So my children are 2 blocks. Now, this is a beautiful question, because now it says, if there are 48 more women than children. So let's look at how many more. There are 8 more blocks in women. Now, what do those 8 more blocks represent? There are 48 more women. So if I take 2 blocks and I say, right, that would be an equal number of women and children. So these are the extra blocks. So there's 8 extra blocks. So therefore 8 blocks are the extra blocks when you're comparing women to children, and that must represent 48 people. And so finally, I can work out what 1 block is. So if I divide by 8, 48 divided by 8 is 6. So it means that every single one of these blocks represents 6 people. Now that would make sense because there would be 48. So there's actually 48, but plus the 12 that match the children. So how many people were there? Well, if they asked me how many women were there were 10 blocks of women, so it's 10 times 6. But this question said how many people in total. So in total, there's 15 blocks. So therefore, the total number of people are 15 blocks of 6 people. So 15 blocks of 6 people represented in each one is 90 people. Now you can always figure out if you're right, because you can go and do some quick maths here and say, well, if these were 10 blocks, so the women are 60 people, the men are 3 blocks, so that would be 18, and the children are 2 blocks, so that would be 12. So check, does that add to 90? And it does. Also check, are there 48 more women than children? Yep. Does 18 out of 90 represent 1/5? Yep. And so you know you're right. Now this particular question, I honestly don't think I could do any other way, because the moment they're comparing two things, I need to know how many blocks each of them have so that I can compare them. So really nice question. Now please don't get worried at all if you find this type of question quite difficult. It is quite difficult. So the more you practice, the better you get. And we're going to do lots more bar models when we do ratio and rate next. And then we'll become absolute geniuses at this, which is great. Well done, guys. Hope it was fun.